our first question here asks us to complete this proof. Now, this should be a question we've seen a multitude of times. We're just trying to fill this in. But even if we don't look at the answers, right? If I see, the first thing I'm trying to answer here is what is being meant by angle A is congruent to angle A. So they tell me a couple of things, and I already showed them to me. They show me that DF, this line right here, is running parallel to this line right here. All right? Anytime that I see two parallel lines, I should look for transversals, right? Does that make sense? So if I have two parallel lines cut by a transversal, that's going to harken back to lesson 12 information, which is corresponding angles are congruent, right? If I have two parallel lines cut by a transversal, then corresponding angles are congruent. So that's going to end up telling me that, ADF, this guy right here, and angle B are congruent, corresponding angles are congruent. Because ultimately, what we are getting out of this, notice that they're saying AD over DB is proportionate to AF over FC. So what they are getting you to is showing you that this triangle right here is proportional to this triangle right here. So by the time we get to 3, notice it's saying angle A is congruent to angle A. If I have a part of a figure that's congruent to the exact same part, what is the terminology that we use there? It's what? Angle A is congruent to angle A. What terminology, what proves that? What's my reason? They're the exact same thing. So what were you saying, Erica? Reflexive, right? That's the reflexive property. So we scroll down here, one of the things we should see is, okay, it's not the transitive property, is it? Right? It's reflexive. Okay, reflexive property of congruence. And so we see that in both B and D, this reflexive property of congruence. And so if I scroll back up here, and I'll try to match that as best as I can, we're getting that this angle is congruent to that angle, right? Does that make sense? Because we're not looking at a trapezoid in a triangle. We're looking at this little triangle on top congruent to this big triangle right here. If you need to, look at them as two separate things like this. Okay? So far what they have said is that this angle is congruent to this angle, and this angle is congruent to that angle. Does that help? Sometimes it helps to separate the two triangles completely away from each other and look at what it is that you have. After that, they say that triangle ADF, which is, we'd be talking about this right here, ADF, is similar, notice that they're not saying congruent because they're obviously not congruent, is similar to triangle ABC. All right? Do I have enough information to say that those two triangles are similar to each other? Well, they say that we do. All right? So what would be the similarity postulate that we would use there based upon what we have? Angle similarity postulate, right? Right? Because that's what I have. So again, right, once we use what we have, we should be able to come down here and say, okay, well, I know it's reflexive, and I know that part number 2 is angle. That's already getting me B, correct? Now, hopefully what we see after all of this is that by the time we get here, right, look at step 7. What have they done to get from step 7 to step 8? What did they do? They subtracted. What did they subtract? They subtracted 1 across to the other side, right? So that's really not too hard to see the subtraction property of equality. Do you understand how we get 1, 2, and 3? Okay? If nothing else, if we got 1 and 2, we should be able to, because ultimately in this question, our answer is going to end up being our answer. But I do, if I was going to ask for work on this, I would probably say, draw me this picture right here, right? If you can draw me that picture right there, you understand how to get A or how to get parts 1 and 2, right? Correct? Okay? Can we do this? You could show me that picture for your work. You could put that in your box. That would give me enough information rather than just say your answer is your answer. Give me this picture right here. All right. A lot of what this review video is good for is telling you what do I need to show. Let's get to question number 2. Which type of transformation takes quadrilateral A, B, C, D to quadrilateral A prime, B prime, C prime, B prime? So we are going from here to here. Can anybody tell me what you would use to go from the blue to the red? Is that are we translating it? Are we moving it, to the left, right, up or down? No. All right. Are we rotating it to get there? No. Are we reflecting it to get there? All right. Is it a dilation? Here's the problem with a dilation. A dilation changes what? Size, but it does not change shape. Is the shape changed here? So it's neither a reflection, a translation, or rotation, because all of those are isometric, right? You don't change the size or the shape in those. And in a dilation, you change the size, but you don't change the shape. Yes, they're both trapezoids, but they're not the same shape. They're not proportional to each other, which is why we would get none correct here. Okay? And if I was to write something in the box on that, I'd say none correct. The shape is changed. Okay? Change of shape, which doesn't fit any of those. All right. Let's come across to number 3. Which of the following is the mapping notation for a transformation of a reflection T across the y-axis? So in a question like this, I would start off with an xy coordinate plane. We got y, we got x, correct? All right, let's say I have point T. We're going to say T, and we're going to say that that's coordinate 1, 1. If I reflect that across the y-axis, what's the coordinates of T prime? Anybody know? Am I going to the left or am I going down? To the left, okay? So I'm going directly across to the left. So that's T prime. What would it be? Negative 1, 1. So what you need to see happens, what happens to the x value? Changes to a what? A negative. But it stays, we keep the number, right? All we did was we changed the sign. Did the y value change? So when we map across the y-axis, our x value becomes opposite, our y value stays the same. What does that match up here? A, B, C, or D? A, right? So you would show me a picture of how that works from here to here, right? And then you would show me your answer A. Okay? I don't want you to just memorize answers. I want you to understand how the work applies. Okay? That way, if the question changes, because if the question on the test may very well be, let's reflect T across the x-axis. If we reflect across the x-axis, does the x value change? No, but does the y value change? Yeah, the y is going to become the opposite. So if we map across the x-axis, we get x negative y, correct? All right. All right, let's look at 4. 8, 3 is a point on circle K, and the center of circle K is 8, negative 8. Then which of the following could be an equation for circle K? Let's take our center and let's write the equation, right? Even, let's see how close you can get. I'm going to start off with what? X. All right. My center is 8, negative 8. So I'm going to write x what? Minus what? 8. Parentheses squared. Very good. Plus y plus squared. Now, granted, at this point, my options are 25, right? But if we look at it, what's the difference? Because those values are the same. There's no difference there. So we're going from negative 8 to negative 3. What's the distance between negative 8 and negative 3? 5. What do I do with 5? Square it, and I get 25. Okay? So x minus 8, y plus 8 equals 25. Right, you're going to get that right there. At the very least, what you could show me is, show me that the difference, negative 3 minus negative 8 equals 5. Show me how you get that radius. Does that make sense? All right, the rest of it is just applying the center. There's really no work to show with that. All right, let's come down to number 5. All right, an artist designs a rectangular quilt piece with different types of ribbon that go from the corner to the center of the quilt. The dimensions of the rectangle are AB equals 10. At this point, it's really just a matter of drawing this picture on your paper and filling in some of the information. AB is 10. AC, that is this guy right here, is 14. Okay? Find BX. We want to find this red thing right here. Now, what do we know about diagonals of parallelograms? We have 4 rules for parallelograms. Does anybody remember the diagonal? You guys go back and look. Diagonals of parallelograms. I can wait. The diagonals, not necessarily. They bisect each other. All right, they bisect each other, which means at point X, right, the AX and XC are the same length. What are the rules for the diagonals of a rectangle? All right, let's take this for a second. If in a parallelogram, diagonals bisect, what is AX if AC is 14? What? What is AX, the distance from A to X? 7, okay? So you're going to take 14, divided by 2 equals 7, okay? What do I know about the diagonals of a rectangle? They're congruent, okay? Which means we know that BD is 14, so we know that BX is 7, right? Okay? So that's how I'm going to get 7 there. I don't know if you guys are checking my answers as I go here, because I'm not. Does anybody want to scroll down to the bottom and see if I'm right there with 7? We are. What do I need to do to complete this question? Anybody know? What have I forgotten to include? Inches, because we have a label, we need to include our label. All right, let's look at 6. Have we seen this question before on a test? Yeah. Anybody ever get this one wrong? Yeah. All right. This is a proportion. One of the number one things I see people get wrong is they say, well, this is 2, so this must be 2. No. If that was the case, then wouldn't NM have to be 8? But it's not 8, right? Which means we're dealing with proportions. So we're dealing with NP over 5 equals what? NP over 5 equals what? So you're saying that NP is to MQ? Or is NP to QR? Well, what is the length of QR? 2. Okay? And that means that NM is to MQ, right? So I need 2 over what? 8. Okay? So 5 times 2 is 10, divided by 8 is 1.25, right? You've got to show me that work, and you need to complete it, okay? Preferably with 10 divided by 8, 1.25. Or if you have to, I'll take 1 1/4. Let's see, beyond that, let's see. What would that be? I'm trying to think of what the mixed number is on that. 1 1/4. Would that be 5/4? Something like that. That should be right. So I'll take 5/4, I'll take 1 1/4, I'll take 1.25. Okay? I think that's being pretty lenient there. All right. Let's see, 7. This is a good question. I haven't seen something like this in a little while, actually. It says the point is chosen randomly. Find the probability. Okay? What is probability, class? All right, we got to start off with it is a ratio, correct? Let's start with it's a ratio. What goes on top of that ratio? Number desired over what? Over number total. Okay? All right. So with this, a point is chosen randomly on AC. Find the probability that the point is not on AB. So what is my desired? What number represents the desired? If I says not on segment AB, 2. Okay, so I'm going to go 2 over what? 8. 2 over 8. So I could write 1 over 4, correct? There's a 1 in 4 probability that a spot chosen randomly on that line segment will be in BC rather than AB. Okay? So you need to remember what probability is, okay? Because we can use probability in all kinds of different forms, whether it's area or length or what have you. Okay? Let's come from down here to number 8, and we'll look at more probability. Again, hopefully we remember what probability is. We've seen a question like this. I think you might even see a question like this on your test, so any of these you want to listen up. Circle is inscribed in a square with a side length of 4. Okay, important word there. Square and circle, right? Because we know specific things about a square, we know specific things about a circle, and it's inscribed. So that means that the radius, you know, is half the diameter. The diameter represents the side length of that square, correct? All right, good. All right, if a point in the square is chosen at random, what is the probability that the point is in the square but not in the circle? Okay? Express your answer as a percent, round to the nearest tenth. So the first thing you need to understand, or what you need to look for, is what is my desired? All right, well, my desired is these funky little corner pieces. Okay? And because it's area and not length, I need to find the area of my blue over the area of the total. All right, what is representing the total? Is it the circle or the square? What is it? Square represents the total. All right, how do I find the area of a square? Goodness, it's awfully quiet in here. Shamefully quiet. How do you find the area of a square? Length times width, right? In this case, length and width, because it's a square, are the same. So what am I multiplying to get my square area? 4 and 4. So what's the area of the square? 16. So because that's my total, that's what I'm going to divide by. Question for you, though. How do I find the area of the shaded region? Okay, say that again for me. That's exactly right. Now, you probably didn't hear that on the recording, but you're going to find the area of the circle, and you're going to subtract that from the area of the square. Okay? So, you know, almost imagine it like a puzzle or something like that, where this is the whole thing, and if I pull a piece out, what I have left is my shaded region. Okay? In my case, what I would say is, you know, we're going to do square minus circle, right? Okay? Do we already know what the area of the square is? Yes. All right. So, you know, if I'm going to fix this up here a little bit, or kind of box that off. So what I'm saying is 16 minus something divided by 16. All right. So I need to subtract the area of the circle. How do I find the area of a circle? Do I have a formula for that? Pi r squared. Okay. So I need to subtract, but I'm going to subtract all of it. I need to be careful with this because it's 16 minus pi, and then multiply that by radius squared and get the wrong answer. So I'm going to subtract it by all of pi r. What is my r here? 2. Because my diameter is 4, my radius will be half the diameter. So pi 2 squared. All right, well, what is 2 squared? 4. So if I needed to simplify this, I could say I'm going to take 16 minus 4 pi, and then I'm going to divide that by 16. All right, so let's come over here to our calculator. Okay, let's get our numerator. We got 16 minus 4 pi. We're going to be as exact as we can. Okay, and I'm going to divide that by 16. I'm getting 0.21, but what does it say it wants my answer in? Percent. What is 0.21 as a percent? 21, you know, and you could say 21.5%, you know, something like that. Somebody scroll down to the bottom for the percent. 21.5%? 21.5%. Because they do say to the nearest tenth, don't they? All right, so 21.5%. All right, I want to take my time with that because that's a really easy one for somebody to see on a test and then just everything that they've heard fly out the window. So, all right, we've got that one. Let's click out of that. Let's come down to number 9. I at least want to try to cover we'll cover what we can today. All right, for an art project, Anna needs to spray paint a soup can on all sides, including the bases. The can is 4 inches tall, has a radius of 1 inch. Find the area to be painted to the nearest square inch. What kind of area are we talking about? Right, because it's a 3-dimensional figure. What 2 types of areas do we have? We have 2 different types of areas when we start talking about 3-dimensional figures. Can anybody tell me what one type of area is? Surface area, right? Define surface area for me. Okay, tell me what the other kind of area is then. Lateral area. What's the difference between lateral area and surface area? Surface area is all sides. Lateral area is all sides except the bases, right? There may be, if it's a prism, it'll have 2 bases. If it's a cone or a pyramid, it'll only have 1 base, right? All right, so we want the area of all sides. So we want the lateral area plus the 2 bases because it's a soup can. It has 2 parallel sides. It's a, for lack of a better way of defining it, a circular prism. Does anybody remember the surface area formula for a cylinder, right? Because that's what a soup can is. Anybody remember it? And don't tell me, you know, lateral area plus 2 times the base, right? Because that is not going to help you on test day. All right, I want the full expanded version of it. And because I put it in your notes, right, I put it on the board several times, you're going to tell me what it is. All right, Brady? 2 pi r, okay. 2 pi r h, okay. Plus 2 pi r squared. And to break this down so that you understand what this is, 2 pi r is the circumference of the base, right? Height multiplies that thing up. So, you know, and I know you can't see this, but imagine this is the label of that soup can, right? This, the length of it is the circumference, right? Notice how the length of this paper becomes the circumference of the circle, all right? The width is the height. So what this is giving me is it's giving me that wraparound, which is essentially a rectangle. Then I'm going to add the top and the bottom to it. Notice that it's 2 pi r squared. What is pi r squared representing? What is pi r squared as a formula? If you know what the formula represents, it's going to be a whole lot easier to remember why it works. What is pi r squared? Area of a circle. Why am I multiplying it times 2? Because I've got 2 bases. Okay. Now, let's come in here and let's put in some numbers where we're missing things. 2 pi. What was the radius? 1. What was the height? 4 plus 2 pi. Radius was 1 squared. All right. What's 1 times 4? What's 4 times 2? 8. So I got 8 pi plus, what's 1 squared? What's 1 times 2? Okay. What's 8 pi plus 2 pi? 10 pi. All right, so all I really have to do is type in my calculator 10 pi. Okay, 10 pi right? And I get 31. It says it wants it to the nearest square inch, so I'm probably good at 31 inches. 31 inches squared. Is that the answer at the bottom? What's that? 31 inches squared. Okay, but you got to know the formula. Okay. All right. Oh, we moved way down here. Number 10. This is going to be really similar to Erica's question from the lesson today. We want to be able to find the measure of W, X, Y. That is this guy right here. Erica, can you tell me how I'm going to find that angle? Your question was the exact opposite, right? They gave you the angle and asked, how do we find, what do we do to find the arc? Here we have the arc. How do we find the angle? Divide by 2. 214 divided by 2. Okay. What was that? 107? 107 degrees. Okay. Very good. All right. That's probably, let's see, you guys out of here at what, 48? Oh, I've got a couple minutes here. All right, so we've got that one. Let's see, let's get question number 11. Find the magnitude. What's another name for magnitude? What am I finding when I'm finding magnitude? Distance, right? 6 tells me I'm going to the right 6. -3 tells me I'm going 3 down. But my distances are still 6 and -3, but the distance I'm trying to find, if I imagine this, I'm going 1, 2, 3, 4, 5, 6, down 1, 2, 3, but my vector is this. So if you look closely, what you have formed is a right triangle where this is 6 and this has a distance of 3. What am I using to solve that? Pythagorean theorem, right? So 6 squared plus 3 squared. What's 6 squared? What's 3 squared? What's 36 plus 9? 36 plus 9. What is it? 45. All right, so what we're saying is that 45 equals c squared. So what are we going to do with that 45? Square root it, and then we're going to simplify it. It says to the nearest tenth, so what am I going to do with that? To the nearest tenth. So what do I do with it? Do I simplify the radical, or do I plug it in my calculator and get a decimal? Plug it in your calculator and get a decimal. Plug it in your calculator and get a decimal. 6.7. 6.7, and it doesn't tell me. We'll say units, or just units, because it's distance, right? It's not distance squared, it's not area. All right, is that the answer in the bottom? 6.7? Okay, great. So we made it to question number 11. I'll pick it up with you guys probably tomorrow. I'll end this video right here. The other class can watch that during their time. So, all right. Thank you for your attention, and please remind me that we are picking up with question number 12 tomorrow.